Simplifying algebraic fractions. Learning intentions. Simplify algebraic fractions by cancelling factors. Add or subtract algebraic fractions using a common denominator. Tidy complex fractions, a fraction over a fraction. Success criteria I can. Factor the numerator or denominator and cancel common factors. Find the lowest common denominator, combine the fractions and simplify fully. Clear complex fractions using the lowest common denominator and simplify. State any values that make a denominator 0 and exclude them. Algebraic fractions are added, subtracted, multiplied and divided in the same way as numerical fractions. So if we're adding fractions here, we're adding fifths and sevenths. We get 35ths as the common denominator. Fractions can only be added or subtracted when they have the same denominator. So they have the LCD, the lowest common denominator. In the second example, we're multiplying fractions. And what we do is top by top, bottom by bottom. So fractions are multiplied by multiplying the numerators and denominators separately. When we're dividing fractions, we turn the second fraction upside down and then we change divide to multiply. And then we do top by top, bottom by bottom. So fractions are divided by changing the division into a product. Note that if we have 6 multiplied by 12 divided by 3, that's going to equal 24. And if we have 6 plus 12 divided by 3, that's going to equal 6. Notice how we are cancelling. So 6 multiplied by 12 can be seen as one term. So we are dividing 3 into the top, so into the 6. So 6 divided by 3 is 2. And we're dividing 3 into the bottom. 3 divided by 3 is 1. But over here we have 3 separate terms. We have 6, 12 and 3. So we can divide the 3 into the 6, into the 12 and into the 3. So 6 divided by 3 is 2, 12 divided by 3 is 4, and 3 divided by 3 is 1. Similarly with algebraic terms, here we are adding or we are subtracting to algebraic fractions. So what we have to do is get a common denominator. You'll see examples of them done in detail in a few minutes. And then we just simplify at the end. In the second example, we are multiplying two algebraic fractions. So we're going to do top by top, bottom by bottom. And in the third example, we are dividing two algebraic fractions. So we turn the second fraction upside down and then we multiply. So changing division to multiplication and then dividing above and below by a common factor. Always check at the end, can you simplify further? So in general, when dealing with algebraic fractions, a common denominator is needed to add or subtract fractions. A fraction can be reduced or simplified only if the numerator and denominator have a common factor. If the denominator or numerator contain fractions added or subtracted, they must be reduced into a single fraction first before proceeding. And to divide fractions, we multiply by the denominator inverted. So let's have a look at some examples. So we want to simplify each of these algebraic fractions. Part 1, we have 5ax over 15a plus 10a squared. So I'm going to rewrite 10a squared as 10aa, and then I'm going to see what letters I can cancel. So I can cancel out an a from each of the 3 terms, leaving me with 15x over 15 plus 10a. Now let's see what numbers I can divide into each of the 3 terms. So I can divide 5 into the top and 5 into the bottom. And remember, when you're simplifying fractions, what you do to the top, you do to the bottom. What you do to the bottom, you do to the top. 15 divided by 5 is 3. 15 divided by 5 is 3. 10 divided by 5 is 2. So you get 3x over 3 plus 2a. Or what we could have done is we could have factorized. So the denominator, 15a plus 10a squared, we could have factorized the 5a, taken out the 5a as the highest common factor, and rewrote it as 5a times 3 plus 2a. And then the numerator we could have factorized and rewrote as 5a times x. And then hopefully you notice we've got a common factor that we can divide. So the 5a's will cancel, leaving us with x over 3 plus 2a. So you can go with whichever method you prefer. Part 2, we want to simplify t squared plus 3t minus 4 over t squared minus 16. So we want to always see if we can factorize. So we're going to factorize the numerator. So we've got t squared plus 3t minus 4. So we're going to get the factors of the 4, which is the constant at the end. So 1 and 4 and 2 and 2. We bring down the t squared. We bring down the minus 4. This is a minus, which tells me that these two signs are going to be different. So one's a plus and one's a minus. I need to choose one of these factor pairs so that when I subtract them, I get 3. So I go with 1 and 4. So I'm going to have 4t minus 1t gives me 3t. Then I factorize the first two terms and I get t times t plus 4. I factorize the second two terms, I get minus 1 times t plus 4. I can put the t plus 4's together inside one set of brackets. That's the first part of my answer. And then the t and the minus 1 go into the second bracket. So I can rewrite my numerator now as t plus 4 times t minus 1. Next, I'm going to have a look at the denominator, t squared minus 16, and see if I can factorize that. So hopefully you can notice that this is the difference of two squares. So I've got two sets of brackets, one's a plus, one's a minus. It doesn't matter which way you put these. I'm going to factorize the first term. So the square root, or I'm going to square root the first term. So the square root of t squared is t. So that goes in the front of both brackets. And the square root of 16 is 4. So that goes in the back of both brackets. So this is known as the difference of two squares. So this is now going to be my denominator. So I have t plus 4 times t minus 4. Now hopefully you notice we've got a common factor above and below, so we're going to cancel out the t plus 4's. So we're left with t minus 1 over t minus 4. Why can we not cancel out the t's? So why can we not cancel out these two t's here? We would have to cancel them from all 4 terms. So if the minus 1 had a t stuck onto it, or the minus 4 had a t stuck onto it, then we could cancel all the t's. But technically what you have here is 4 separate terms. You've got t, minus 1, t, and minus 4. So in order to cancel out the t's, you have to cancel them from each and every term. So all 4 terms have to have a common factor that you can cancel. Part 3. 5 over 8 plus y divided by 1 over 8. So the rule for dividing fractions, turn the second fraction upside down and then multiply. So this divide line here, this big long divide line becomes multiply, and 1 over 8 becomes 8 over 1, which is the same thing as 8. Then we're going to multiply. 5 over 8 times 8 is going to be 40 over 8. And y times 8 is going to be 8y. And 40 over 8 is 5. So we get 5 plus 8y. Example 2. Simplify each of the following. So we are subtracting two algebraic fractions here, and the rule is we have to get a common denominator. So we can just stick the two denominators together, and I've highlighted them so that you can see them clearly. They're just stuck together with brackets. This is our common denominator. So then we're going to say, well, x times x plus 4y divides into this common denominator, and the yellow parts will cancel, leaving us with 2x. So we're going to do 6y multiplied by 2x. So 6y multiplied by 2x. Then we bring down the minus, and then we do the same thing. We say, well, 2x divides into this denominator, and the 2x will cancel, leaving us with x times x plus 4y. So it's going to be x times x plus 4y multiplied by 3. So 3 times x plus 4y. So next we multiply out our numerator. So 6y times 2x is 12xy. And minus 3 by x. Well, what I'm going to do is just multiply out inside the brackets first. So I'll bring down the minus 3 and an empty set of brackets. And then x times x is x squared, and x times 4y is plus 4xy. And that's all over the common denominator. So I'm just writing that down exactly as it is above. So then we have our 12xy. And then minus 3 by x squared is minus 3x squared. And minus 3 by 4xy is minus 12xy. And again, that's all over the common denominator. Hopefully you can notice that 12xy and minus 12xy will cancel. So we've got minus 3x squared all over x times x plus 4y times 2x. Now minus 3x squared is really minus 3xx. And that x can cancel with that x. And that x can cancel with that x. And we're left with minus 3 over 2 times x plus 4y. So we don't need to actually multiply this out because it's factorized already, so that's in its simplest form. So that's our answer. Part 2, we have x minus 4 over x squared minus x minus 2, all minus x minus 3 over x squared minus 4. So we're going to do some rough work. We're going to factorize x squared minus x minus 2. We're going to bring down the x squared. We're going to bring down the minus 2. This is a minus, which tells us that these signs are different. So one is a plus and one is a minus. The only factors of 2 are 1 and 2 because it's a prime number. So we're going to go with 1 and 2. So it's going to be plus 1x minus 2x will give us minus 1x. Then we factorize the first two terms and we get x times x plus 1. We factorize the second two terms, we get minus 2 times x plus 1. So since we have the same thing in both sets of brackets, that's the first part of our answer. And then x minus 2 goes into the second bracket. So now we have factorized our denominator, so we can just rewrite it as x plus 1 times x minus 2. So I have x minus 4 all over x plus 1 times x minus 2. And then my second fraction, hopefully you notice that the denominator can be factorized using the difference of two squares. Don't forget the minus, actually, that's really important, the minus. So x squared minus 4, we're going to open up two sets of brackets, one's a plus, one's a minus. The square root of x squared is x, that goes in the front of both brackets. The square root of 4 is 2, that goes in the back of both brackets. And here we have our factors. So this is known as the difference of two squares. So this is going to replace our denominator. So we have x minus 3 still on top, and then x plus 2 times x minus 2. So now we are subtracting algebraic fractions, so we have to get a common denominator, and hopefully you notice that we have a matching, we have a common factor, so highlighted there in blue is the x minus 2 common to both. So when we're sticking together our factors, we don't use this twice, so we are only going to use one of the blue parts. So we bring down the x plus 1 with brackets around it, we bring down the x minus 2 with brackets around it, and we bring down the x plus 2 with brackets around it. We don't bring down a second x minus 2. So then we say x plus 1 times x minus 2 will divide into our common denominator and leave us with x plus 2. So we're going to do x plus 2 multiplied by x minus 4. Then we have our minus. And then we say x plus 2 times x minus 2 will divide into the common denominator, and the blue and the green parts will cancel, leaving us with the yellow part. So it's going to be x plus 1 multiplied by x minus 3. So then we multiply out the numerators. So I'm going to do the x minus 4 times x plus 2 as rough work over here. So that ends up being x squared minus 2x minus 8. So we have x squared minus 2x minus 8. And then we bring over the minus, don't forget the minus, and an empty set of brackets. And then in the rough work, I'm going to work out x minus 3 times x plus 1. So I get x squared minus 2x minus 3, which goes into these brackets. So then I'm going to multiply in the minus. So I'm just bringing over the x squared minus 2x minus 8. So I'm just writing that down, not changing anything there. Then I'm going to multiply in the minus. So minus times x squared is minus x squared. Minus times minus 2x is plus 2x. And minus times minus 3 is plus 6. And then I have my common denominator again. So then hopefully you notice that the x squared will cancel with the minus x squared, and the minus 2x will cancel with the positive 2x. And then minus 8 plus 3 is minus 5. And then we can change the x minus 2 times x plus 2 into x squared minus 4. So this is the difference of two squares. And this is our final answer.